It's dark and incredibly cold. There's no oxygen. There's no water. There's no life. But the James Webb Space Telescope doesn't seem bothered by all this. Its main goal is to find the very first galaxies that formed billions of years ago in the early universe and observe the stars making up distant planetary systems. Its mission is to... But wait, what is that? The James Webb Space Telescope has discovered something absolutely amazing. A star-planet hybrid with very strange clouds. This bizarre world called VHS 1256b is actually a brown dwarf. Those are bigger than planets, but too small to classify as stars. They emit some light of their own and are quite hot, but their mass is simply not enough to fuse hydrogen into helium, like full-fledged stars do. Space bodies of this kind aren't actually brown. They occur in a wide variety of colors, but those are mostly invisible to the human eye. What we can see is the light they emit, and to us it appears to be dark orange or magenta. The brown dwarf we're talking about is almost 20 times the size of Jupiter. It orbits 2 red dwarf stars. And to complete one orbit, the brown dwarf needs 17,000 years. In fact, astronomers found out about this unusual exoplanet in 2016. But at that time, they didn't classify it as a brown dwarf, and thus couldn't explain its puzzling reddish glow. Now, thanks to the James Webb Telescope, they know the space object's origin. Anyway, back to those clouds. As you know, clouds on Earth are made of water vapor, but those on the brown dwarf are different. They seem to be made of sand. It looks like good old sand from Earth, but it's actually not. The clouds are made of tiny particles of silicate. Scientists have been putting forward theories about the existence of such sand clouds on exoplanets for quite some time. But the discovery the James Webb Space Telescope made is the first real proof. The silicate particles on the sandy dwarf are most likely quartz or some other mineral. In size, they're less than a micron, and 1 micron is 1/25th of a thousandth of an inch. In other words, they look like particles in smog. The exoplanet seems to have an atmosphere which contains some water, methane, and other substances and minerals. Interestingly, this atmosphere isn't still. It's constantly undergoing extreme changes. Another cool thing about it, scientists have detected carbon dioxide. And this is only the second confirmed discovery of this gas on a planet outside the solar system. By the way, the James Webb Space Telescope, with the help of which astronomers discovered our sandy brown dwarf, is an absolutely stunning piece of equipment. Around 100 times more powerful than Hubble. Even though the telescope itself is 3 stories high and its size equals that of a tennis court, its mirrors are the lightest large telescope mirrors of all time. When all the 18 mirrors of the telescope were completed during the manufacturing process, their mass was reduced by 92% in comparison to the initial discs. Each mirror weighed a mere 44 pounds. The telescope's mirrors seem to be gold, but in reality, they're made of beryllium, steel gray, lightweight, and brittle metal. There is indeed a gold coating on each mirror, but they can't be produced entirely out of gold since this material tends to expand and contract even with small temperature changes. That's why the total amount of gold in the James Webb Space Telescope is less than 2 ounces. James Webb's telescope side is cooling itself down, and its temperature doesn't rise higher than -370 degrees Fahrenheit. That's cool enough to make liquid nitrogen. A truly enormous 5-layered sunshield stretches around the telescope and reflects away as much sunlight as possible, letting the telescope stay cool. The telescope was launched near the equator, because Earth spins a bit faster there, and this gave the rocket some extra push. The telescope orbits the Sun more than 1 million miles away from Earth, and when it runs out of fuel, it'll keep orbiting the Sun indefinitely. On the other hand, even though the telescope wasn't actually designed to be serviced or upgraded, it might potentially be refueled with the help of robots. This would extend its life. Anyway, if you think that our newly founded brown dwarf is the only bizarre exoplanet out there, let me show you some other breathtaking worlds. There is an exoplanet that is really something else. Just look at its awesome magenta color. You can find it in the Virgo constellation. The planet is called Gliese 504 b. It orbits very far from its parent star, 9 times the distance between the Sun and Jupiter. The planet formed relatively recently and is still glowing with heat. That's why its surface looks pinkish. One of the oldest exoplanets we know about is about 12.7 billion years old. It's almost 3 times as old as Earth. This also means that the so-called Genesis planet formed only about 1 billion years after the Big Bang. The planet is so old that its 2 parent stars have had enough time to evolve into a white star and a pulsar, making almost 100 revolutions per second. I bet sunrises on this planet must look awesome. Just 20 light years away from the Sun, which isn't such a great distance when we talk about space, a bizarre rogue planet is roaming the Milky Way galaxy. But even though this planet doesn't orbit any star, it still has an incredibly powerful magnetic field. It's 4 million times stronger than Earth's. The exoplanet also produces amazing auroras. That's why when it was discovered in 2016, astronomers were almost sure they had detected a brown dwarf. But later, scientists got some proof that this space object wasn't big enough to be a brown dwarf. The planet sure is a mammoth among its peers. It's 1.2 times as wide as the largest planet in the solar system, Jupiter, and more than 12 times as heavy. Astronomers think the exceptionally strong magnetic field helps the planet produce auroras. But the most curious thing is that they're generated in a different way than auroras on Earth. It might be because the exoplanet's moon helps the planet create mesmerizing light shows. The next exoplanet isn't like any other. It's often called Super Saturn or Saturn on steroids. That's because J1407b has a colossal system of rings. They're 640 times as large as those our Saturn has. This bizarre world is the only planet we know about that has rings similar to Saturn's. If you moved this giant to our solar system and used it to replace Saturn, its rings would look many times larger than a full moon. An exoplanet called WASP-12b munches on the light coming from its star. It's one of the darkest worlds people know about. All because its day side consumes light rather than reflects it back into space. The egg-shaped planet is giant, twice the size of Jupiter, and it traps more than 94% of the light that reaches its atmosphere. It might be the main reason for the temperatures on the surface of the planet that can rise up to 4,600 degrees Fahrenheit. The night side of the planet isn't as hot as its day side, a mere 2,200 degrees Fahrenheit. The difference in temperature makes water vapor and clouds gather above the surface of the planet. And from time to time, swirls of material from the planet's superheated atmosphere spills onto its star. What a view! Discovered in 2017, KELT 9b is one of the hottest exoplanets we know of. The temperatures there can reach 7,800 degrees Fahrenheit. For comparison, the temperatures at the surface of the Sun reach 10,000 degrees Fahrenheit. The planet is probably so insanely hot because it orbits extremely close to its star, KELT 9, which is way hotter and bigger than our Sun. Experts believe that the giant star might one day evaporate the entire planet.
The only life that we are certain about so far in the entire universe is on planet Earth. Whether that life is intelligent is, let's say, arguable. But anyway, it's not surprising that we're tirelessly searching for life on other planets. So far, they've discovered more than 4,000 of them. But what's even cooler? NASA has compiled a new list of 24 planets that aren't just Earth-like, they're better. The conditions on them are so good that they're more comfortable than on our planet. So let's examine some of them. KOI 5715.01. Let's be coy, shall we? This wonderful planet is in the constellation Cygnus. And why is it so wonderful? Well, our Sun is a yellow dwarf. And sorry, Sun, even though you're not bad at supporting life, there are some stars that can do it better. Nothing personal. The planet KOI 5715.01 orbits near an orange dwarf. Orange dwarfs are stars slightly smaller than our Sun and have a little lower luminosity. Did you like the alliteration there? Anyway, don't worry, it doesn't mean we're going to live in complete darkness. In fact, if the planet is found closer to the Sun and it has a thicker atmosphere, it may even be lighter and more colorful than on Earth. Now, our Sun has a very short lifespan. Right now, it has 7 to 8 billion years left to live, a little longer than Earth's age. But orange dwarfs can live from 45 to 70 billion years. This is great not only because we'll be able to hang out on this planet longer, but also because the planets around these stars have more time to form life. Now, ideally, we would need to find a planet next to an orange dwarf that is about 7 billion years old. It's very likely there will be at least some organisms there. KOI 5715.01 is about 5.5 billion years old. Yeah, it may not seem mature enough, but that's okay, neither do I. Our Earth is a billion years younger, and that didn't stop us. The planet is quite close to its star and is in a habitable zone. 1 year there lasts 190 days. Imagine going to elementary school and already getting a driver's license. It's almost 2 times larger than the Earth. The average temperature there is 52 degrees Fahrenheit, which is slightly less than ours, 57. But it mostly feels warmer there because strong gravity helps it hold on to heat in the atmosphere longer. It's a little too far away though, like 3,000 light-years from Earth, which is about 18 quadrillion miles. Yep, better bring a really big lunch with you. KOI 3010.01. This planet is found next to the star KOI 2010. This planet sounds like a very pleasant world. The average temperature on this planet is 67 degrees, so a little warmer than ours, but that's a good thing. Scientists believe that on a perfect planet, the temperature should be just about 10 degrees hotter than on Earth. The more heat there is on the planet, the more comfortable it is to live there. Also, the higher chances of developing life. The radius of this planet is nearly 1.5 times larger than Earth. There's some atmosphere, although we're not yet sure about its composition, but it's probably like the Earth's. Scientists think that we'll find an ocean there, and it can cover up to 60% of the surface, which is also cool. In a perfect world, water and land should be distributed more evenly than on our planet. A little more land means a little more territory and resources, right? But listen, this planet is actually very similar to the Earth. The semblance is so striking that scientists believe we have an 84% chance to find life there. Of course, not necessarily an intelligent life, but at least some animals. Wouldn't that be cool? Now, what do you think they could look like? Very Earth-like planet, but with stronger gravity. Well, if someone lives there, they're probably big but have a small height and strong little legs. Sounds adorable and scary. But we won't be able to find out the truth anytime soon. So far, for us, these planets are microscopic dots in space. We only have some dry, boring data about them and don't even know what they look like. We'll have to wait until we can find a way to get closer to these planets. Kepler 186f. This is also one of the best candidates for having life. This rather cute planet was nicknamed the Earth's cousin because it does have a strong resemblance. Anyway, these two planets are like sisters, not twins. Kepler 186f rotates near a red dwarf. Red dwarfs are stars even dimmer and smaller than orange dwarfs. Yeah, they'll also live for a very, very long time, but their luminosity is also quite low. However, Kepler 186f is closer to its star than we're to our Sun, so it shouldn't be too dark there. Well, at least not night-like dark. The sky on this planet is sure to be an unusual shade of red, like sunsets on Earth. What do you think? Would you like to live on a planet with an eternal sunset? The size of this planet is about the same as Earth. Not bad, not perfect. Why so? Because the coolest planets are those that are bigger than Earth and have stronger gravity. Now you'll probably say, but wouldn't it be harder to walk there and even harder to get out of bed on Monday? Of course. But on the other hand, this planet will pull the atmosphere better. The atmosphere will be thicker and denser. This means more protection from the scary space stuff, more oxygen, and more heat. Not to mention the fact that the bigger planets have more space to settle. Awesome, right? But, of course, the Earth's size is also an excellent choice. Another cool fact is that the tilt of Kepler 186f is about the same as ours. It means that there should be stable seasons and a normal day-night cycle. Do you know how important the tilt of the planet is? Let's look at Mars. Mars is also, in fact, found in the habitable zone of our Sun, but its tilt is very unstable, and as a result, the entire ocean that could have been on it once now completely dried up. Today, it's just a red desert, and there's no life there. At least not as far as we know, but you see how important these tiny details are? This planet is also quite far away from us, 490 light-years. That's about 3 quadrillion miles. So yeah, we're just going to keep waiting for intergalactic travel. Kepler 62e and 62f. These planets were called the most Earth-like before we discovered Kepler 186f. They're very comparable to our home. Kepler 62e is about 1.5 times larger than Earth, and Kepler 62f is just slightly smaller than that. They're located in the constellation Lyra, which is about 1,200 light-years away from us. They both also orbit a red dwarf. 1 year on Kepler 62e lasts about 122 days, even less than on that first planet we talked about. Scientists believe that both 62e and 62f are sort of water worlds, warm places mostly, or even completely covered with water. If there is land there, it's probably just some islands. A world consisting entirely of islands. A fantasy dream for some, think Hawaii, and a nightmare for others, think Megalodon. But if you're a fan of ancient marine animals, just imagine how gigantic they could be there. Still, there are many things we don't know about this planet. Does it have a surface? What about its composition, density? One day, maybe we'll be able to answer these questions. And so, that's it for the super-Earths. Of course, the original list is much longer, and you can go check it out on the internet. Now, the best thing about all this is that these are planets that are better than the Earth. But we also know thousands of other exoplanets that are just close enough to ours. And the odds are, a few of them have at least some form of life. But they're very, very far away, so we have no way to check it out right now. Perhaps, down the road, we'll find some cool creatures on many of them. Guess what? Scientists have come up with a cool idea about some cosmic creatures saying hello to us from the center of the Milky Way. Astronomers are all excited about finding extraterrestrial life, so they're focusing their search right at the heart of our galaxy. Imagine stars in outer space, like super cool DJs, spinning their own unique beats. But instead of music, they send out these special signals called radio pulses. It's their way of saying, "Hey, what's up, universe?" These radio pulses are basically little bursts of energy that travel through space. They're not just random noise, though. They have a specific pattern that makes them stand out from all the other sounds out there. It's like a secret code or a special rhythm that only these stars know how to create. Scientists are super curious about these radio pulses because they think that maybe, just maybe, intelligent beings from other planets could be using them too. It's like a galactic language that they could use to talk to each other. So, these clever scientists created special tools and software to listen in on these signals. It's kind of like tuning into your favorite radio station, but instead of music or talk shows, they're trying to catch these cosmic beats. They're hoping to find those unique patterns that could be a sign of other space beings trying to communicate with us. They used a super cool telescope called the Green Bank Telescope in West Virginia to collect data and search for these signals. But here's the twist. They didn't find anything this time. No worries though, because their fancy software is lightning fast and it'll help them search even better next time. But why did they pick the center of the Milky Way for this ET life hunt? Well, that's because the galaxy's hearts are packed with stars. In other words, there should be many more planets in there, which means more potential places for life. Plus, if there are super smart life forms at the core of our galaxy, they could easily send signals to lots of planets all at once. Sneaky, huh? This whole thing is super exciting because it's the first time scientists have gone all out to search for these types of signals. They think that using specific frequency ranges and repeating patterns is a really clever way for ET beings to make themselves known. I mean, that combo is so unlikely to happen naturally, right? The best part is that they have this algorithm thingy that can go through a crazy amount of telescope data in just 30 minutes. So, even though they didn't find anything yet, they're confident that this speedy method will help them find evidence of advanced life in the future. How awesome would that be? As you know, humanity has been searching for buddies from outer space for a very long time. This research is just one of many attempts to find them. There's a whole institute dedicated to this mission in the US, SETI, or Search for Extraterrestrial Intelligence. So, naturally, the question arises, why haven't we found anyone yet? It's like we've been scanning the sky forever, hoping to catch a glimpse of advanced civilizations out there. But we get absolutely nothing. All this brings us to the famous Fermi paradox. It's like a big mystery that fuels the hunt for extraterrestrial intelligence. We think that if intelligent life exists, we'd have evidence of it by now. Maybe they're actually beaming out radio signals for us to pick up. Or maybe they're just broadcasting in general and we happen to stumble upon it. They could even have left cool artifacts in our solar system to keep an eye on us or just hang out. Heck, maybe they're building wild mega engineering projects, like gigantic solar panels around their stars. Or they could be getting all fancy and contaminating their stars with heavy metals just to announce their presence. So the search continues. We're not giving up just yet. And hey, maybe instead of just focusing on smart space beings, we should be on the lookout for any kind of life at all. Yeah, I know that a tiny microbe might not be as thrilling as chatting with friendly otherworldly creatures. But think about it. There could be lots of simple life forms out there. We're talking about simple organisms swimming in oceans, mossy creatures holding onto rocks, or the first signs of critters exploring their habitats. They might not be super brainy, but they leave their mark. Plus, they could be way more common and easier to find in our galaxy. Now take Earth, for example. There's a theory that our atmosphere used to have a lot of oxygen floating around. But oxygen is a bit wild and doesn't stick around for too long. It either escapes into space or bonds with other elements, changing into different things like carbon dioxide. Then, around 2 billion years ago, single-celled organisms decided to gobble up carbon dioxide and burp out oxygen, completely changing Earth's atmosphere. Life here transformed the very nature of our planet. And guess what? We can actually detect changes like that on other planets. Here's how. When we look at faraway planets called exoplanets, sometimes they cross in front of their parent stars. As the star's light passes through the planet's atmosphere, it gets all mixed up with different elements and molecules in the air. And you know what happens? The light changes its flavor and color in a special way. So imagine you had a glass of lemonade and you added some fruit juice to it. The lemonade would taste different, right? Well, it's kind of like that with exoplanet atmospheres. When we see the star's light that has traveled through the planet's atmosphere, it gives us clues about what's in the air and how it's different from just the star's light alone. So, by studying these changes in light, we can figure out what kinds of elements and molecules are present in the atmosphere of a faraway planet. It's like a cosmic chemistry experiment, and it helps us learn more about whether there might be life out there. So right now, we can only study the atmospheres of big planets that orbit really close to their stars. But don't worry, NASA's Transiting Exoplanet Survey satellite is on the case. It's finding lots of interesting planets that we can check out more closely with the super-powered James Webb Space Telescope. This amazing telescope can even sniff out if there's too much carbon dioxide on other worlds. And okay, let's be real, our first contact probably won't be as flashy as in the movies. No exchanging secret codes or figuring out ET customs. We won't be chatting about funky bodies or habits either. Instead, the first hint of life out there will most likely come as a little wiggly line on a graph. It shows us that living creatures have really shaken things up on their home planet. Even simple life forms can have a big impact on their environment and leave behind a noticeable trace. Sure, it might not be as wild as battling space robots or epic adventures, but imagine this. Finding any kind of life beyond Earth would be huge. We'd be calling home, sending messages like, "Guess what? We're not alone in the universe." It would be an historic moment we're celebrating. And by the way, we've already begun to find organic molecules in space. It's not a full-fledged life as we imagine it, but it's still pretty neat. For example, we've already started to find organic compounds on Mars. And there's a teeny-tiny chance that Mars once flourished with plants, and maybe even animals. This is just a possibility, but if it turns out to be true, it would show that the presence of living organisms in the universe is not as rare as it seems. The search for life in the universe is like a great detective game. We thought that finding it would be easier because they could do cool stuff like blasting radio signals or transforming their whole solar system. But looks like, in reality, things are much more complicated. Nevertheless, we shouldn't give up. Let's keep searching and hoping that this new study about radio signals brings some results.
It's been more than a year since the James Webb Telescope, which had taken over 20 years to complete, was launched. And for such a relatively short time, the ultra-modern and most powerful in history piece of equipment has already made plenty of discoveries. By observing the universe at infrared wavelength, James Webb lets us see things no other telescope has ever shown before. The primary goal of this incredible piece of equipment is to study the formation of galaxies and stars that appeared in the early universe. For example, look at the closest to us stellar nursery, a region of space where new stars get born. NASA has shared an image from James Webb that shows a small star-forming region. If you look at the picture attentively, you'll see jets bursting from infant stars. Around them, different colored clouds of cosmic dust are colliding with one another. The view is mesmerizing. The red dust consists of molecular hydrogen. You can also notice that some stars have something like shadows. Those hint at the creation of what will later become planets. At first sight, the image may seem chaotic, but astronomers claim that it's a relatively small and quiet stellar nursery in comparison to some others. Many young stars there are similar in size to our Sun, or a bit smaller. The photo itself was taken with the help of Webb's near-infrared camera, NIRCam. It's the observatory's primary camera that snaps images of the cosmos in 2 different infrared ranges. Another amazing discovery the Webb telescope has made is smoke molecules in a distant galaxy. It's the first time such molecules have been discovered so far away from our planet. The galaxy in question lies 12.3 billion light-years away from Earth. It most likely formed about 1.5 billion years after the Big Bang. Despite such a huge distance between the galaxy and our planet, scientists have managed to detect chemical compounds found in soot or smoke, and it's quite a big deal since it has pushed the record for detecting similar complex molecules back by around 1 billion years. This study has also confirmed the sheer power of the coolest piece of space equipment of all time. It managed to make this discovery despite the fact that the spectrometer needed for the measurements didn't perform to the fullest after having experienced a sudden and surprising degradation. The James Webb Telescope has also helped to boost our understanding of exoplanets. Those are planets orbiting stars other than our own sun. At the beginning of 2023, the observatory spotted its first exoplanet, LHS 475b. It's located 41 light-years away from Earth and is approximately the same size as our planet. According to NASA, nowadays, James Webb is the only operating telescope capable of categorizing the atmosphere of Earth-sized exoplanets. The research team behind the discovery believes such results underline the precision of the telescope. They hope that it will help us locate many more rocky exoplanets that we might be able to colonize in the future. Even though, at first sight, it may seem that the universe is pretty empty, it's actually a very busy place, and Webb has all the necessary instruments to see all kinds of cosmic events happening out there. Just look at this image of WR-124. It's a star on the cusp of its explosive demise. In the image, the star is about to go supernova. It happens when a star runs out of its fuel and explodes at the end of its life cycle, releasing a giant cloud of space dust and hot gas into space. The star captured by the Webb telescope was at the Wolf-Rayet stage of its life. That's a period when a star is shedding its outer layers before going supernova. The next amazing thing discovered by James Webb is a star-planet hybrid with very strange clouds. This bizarre world, VHS 1256b, is actually a brown dwarf. Those are bigger than planets but too small to classify as stars. They emit some light of their own and are quite hot, but their mass is simply not enough to fuse hydrogen into helium like full-fledged stars do. Space bodies of this kind aren't actually brown. They occur in a wide variety of colors, but those are mostly invisible to the human eye. What we can see is the light they emit, and to us, it appears to be dark orange or magenta. The brown dwarf discovered by the Webb telescope is almost 20 times the size of Jupiter. It orbits 2 red dwarf stars, and to complete one orbit, it needs over 10,000 years. Astronomers first found out about this unusual exoplanet in 2016, but at that time, they didn't classify it as a brown dwarf, and, thus, couldn't explain its puzzling reddish glow. Now, thanks to the James Webb Telescope, they know the space object's origin. Anyway, back to those clouds. As you know, clouds on Earth are made of water vapor, but those on the brown dwarf are different. They seem to be made of sand. It looks like good old sand from Earth, but it's actually not. The clouds are made of tiny particles of silicate. Another recent discovery involves several large galaxies that scientists believe were born not long after the Big Bang. They aren't supposed to be there, and no one expected to find them. But the James Webb Space Telescope has spotted them. These galaxies, as massive as our home Milky Way, are full of mature red stars. Astronomers have analyzed the light coming from them and estimated their age 500 to 700 million years after the Big Bang. It means that they came into being when our universe was very young, almost a baby. But the most bizarre thing about these galaxies is their tremendous size and the age of the stars dwelling there. The data received by the telescope don't coincide with the existing ideas about what the universe looked like and how it evolved in its early years. It also doesn't match the earlier observations made by Hubble. And here, James Webb has captured a distant region of space in unprecedented detail. This section of space is known as Pandora's cluster. In the image, you can see 3 massive clusters of galaxies coming together and forming a megacluster. The combined mass of these clusters acts as a powerful gravitational lens. And thanks to this natural magnification effect, scientists can see other galaxies in the region. Astronomers claim that the most recent image of Pandora's cluster is stronger and deeper than they have ever seen. James Webb has also managed to spot thousands of young stars never seen before in the Tarantula Nebula. This space formation got its nickname because of the appearance of dusty filaments spotted in previous images. It's the biggest star-forming region in the local group, which includes the galaxies nearest to the Milky Way. The Webb telescope's images have helped to shed light on the composition of the Tarantula Nebula. The telescope has also detected protostars, infant stars in the process of gaining mass. Astronomers expect that these protostars will eventually form and shape the nebula further. Among other discoveries made by the James Webb Telescope, you can see the birth of 50 distant stars. Some of them power protoplanetary disks, which might later form solar systems light years away from our own. Here's one more image from James Webb. You can see a supermassive black hole that has a mass of 9 billion suns. It's so ginormous and ancient that scientists are struggling to explain its existence. Astronomers have also discovered a distant ring of dust, rock, and gas that contains a chemical called methylcation. It's known as a molecular building block of life, and it makes most of the organic material on our planet. James Webb helped researchers see powerful sandstorms on a planet 235 trillion miles away. Astronomers were happy to discover this treasure chest of countless tiny sand particles. Now look at this. Do you recognize this image? Those are the so-called pillars of creation. But this new view shows us just how star-speckled that dusty region actually is. You can compare the new photo with the one taken by Hubble in 2014. This is astonishing proof of scientific progress.
Right now, 4 tiny, Earth-like planets are chilling around one of the closest star systems to us. We're talking second closest. These little rocky worlds are each about 20 to 30% the mass of Earth. So not quite Earth 2.0, but still pretty solid. Will one of them become our new home one day? Well, all of them are pretty close, so future humans might actually visit them someday. Not like next year or anything, but we could potentially send missions there. Don't expect any extraterrestrial neighbors though. Those planets probably aren't home to life, or at least not anything we'd recognize. Let's take a look at them. The planets are called Bernard B, C, D, and E. How creative, huh? The innermost has a mass of 26% of Earth. The second one is a bit bigger, with a mass of 30% of Earth. The third one has 4% more mass than the previous. And the outermost is... no, it's not the biggest. Actually, it's just a baby, with a mass of 19% of Earth. All the planets are likely rocky, like the inner planets of our solar system. They orbit their star very closely. That's why they only need a few days, under a week, to make a full circle. Now, what about that star these little guys are circling? It's called Bernard's star. Astronomers have always had a hunch there might be at least one planet orbiting it. First off, this star is super close, in cosmic terms of course. Only the Alpha Centauri trio is closer to us. Bernard's star is just under 6 light-years away, which is basically next door. At the same time, it's not like our Sun. Bernard's star is a red dwarf, the most common kind of star out there. It's got only about 1/6 the mass of the Sun. But red dwarfs are a goldmine for learning about planets outside our solar system. And studying Bernard's star can help scientists figure out what planets around single stars, like our Sun or this red dwarf, are like. Or what kind of environments red dwarf planets might have. And most importantly, we might finally find the answer to this super important question. Could any of these places actually support life? For the longest time, scientists thought there might be a big Jupiter-like gas giant hanging out near Bernard's star. All because the star has a little wobble. It looks as if it shifts towards and away from Earth over time, so something might be tugging on it. Interestingly, it wasn't a giant planet doing the pulling. According to a study from March 2025, it's actually 4 smaller rocky planets, each about 4 times the mass of Mercury. One day, they ganged up and started tugging on the star together. These planets are incredibly close to their star, so close that they can whip around it in just a few days. Sadly, because of that, they might be way too hot for anything like life. Besides, since these 4 seem to explain all the star's movement, the researchers think there's probably nothing else orbiting the habitable zone. So, there's no Earth 2.0 orbiting around Bernard's star. Still, it's an awesome find, especially since this star is basically our cosmic neighbor. Plus, the system might not stay off limits forever. With nuclear fusion engines or light sails, futuristic propulsion systems that could make the trip way faster. We might probably go there one day. And then we'll finally figure out if these worlds are really lifeless and maybe even colonize them. Now, let's see how scientists found the star's hidden planets. Normally, astronomers spot exoplanets when they catch them crossing in front of their stars and blocking some light. But Bernard's star is tricky, because in our view, it's like we're looking from above the system, so its planets don't block the light in the usual way. That's why they call it the Great White Whale of planet hunting. To get around this, researchers used a super sensitive instrument called Maroon X attached to the Gemini North telescope on Hawaii's Mauna Kea volcano. Over 112 nights, spread out across 3 years, the telescope picked up tiny changes in the star's movement. These shifts let scientists figure out how many planets must be tugging on the star, as well as estimate their sizes. At first, they found 3 planets. But then they used another device, deliciously called Espresso, and located at the Very Large Telescope in Chile. And only after a shot of this espresso did they find a 4th planet. By combining the data from both instruments, they were able to more or less confidently say their findings were solid, not just random glitches in the data. Even though red dwarfs, like Bernard's star, are the most common type of star in the universe, most are way too far for us to see planets around them easily. These new findings suggest that small rocky planets could be pretty common around these stars, and that's huge for future discoveries. Now, finding new exoplanets is cool and all, but it might be even more exciting to dwell on their birth and evolution. And a recent study has made the sweetest discovery ever. Newly born exoplanets might actually look like Smarties, that popular British candy, rather than spheres. We've always kinda assumed that baby planets are born ball-shaped, but they might be oblate spheroids instead. A team of scientists from the University of Central Lancashire in England used computer simulations to build a model of the formation of planets in dense gas disks surrounding young stars. After that, they compared these models with actual observations and noticed that the young planets took pretty unusual shapes. The thing is that even though almost 6,000 exoplanets have been discovered so far, astronomers still don't have a clear understanding of the sequence of events marking their birth and early evolution. But this new research might finally shed light on this process. So, the astronomers examined the formation mechanisms of gas giant planets like Jupiter and came to the conclusion that planets built up from their centers. After that, the researchers focused on the initial shapes of such planets. They were also interested in how they could encourage the growth of these planetary seeds. How could they turn into such massive planets, some of them bigger than our solar system's largest giants? According to the standard theory of the formation of planets, such growth happens gradually and smoothly. First, dust particles start to stick together, turning into larger and larger objects. This process lasts for a very long time and is known as core accretion. It's the model of planet formation scientists favor. There's another theory, according to which planets' birth might happen over shorter periods of time. This data involves a protoplanetary disk, a disk of gas which makes up 99% of its mass, and dust, around 1%. This disk orbits a newly formed star, and hypothetically, planets might form from this cloud. Protoplanetary disks are likely to be common byproducts of star formation. They might range in mass from 0.001 to 0.3 solar masses. Inside such disks, matter slowly moves inward, and dust particles grow bigger, to the size of pebbles. At one point, after 2 to 3 million years, a giant rotating protoplanetary disk breaks into pieces, and that's how baby planets are born. This theory is known as the disk instability model. As for the model built by the team, it seems to support this second, less favored theory: rapid planet formation through disk instability. All because this theory explains how large planets can form relatively quickly at pretty large distances from their host stars. As for the weird flattened shape of these newly formed planets, it might be due to the material falling onto them. Most likely, it goes mainly to the poles of new planets. One of the main conclusions of the research is that the appearance of young exoplanets, as we see them from Earth, may vary depending on how they're angled. If Earth is directed face-on to an exoplanet, it will seem that the latter has a traditional spherical shape. But if seen on edge, a baby exoplanet will look like a real smarty. The team is going to continue to investigate the formation of planets with the help of an improved computer model. They believe they can find out the role the environment around a young planet plays in affecting its shape and formation.
Bang! Or should I say, Big Bang. The Big Bang. Ahem. So after the Big Bang, the universe resembled a hot soup of protons, neutrons, and electrons. After it started to cool down, the protons and neutrons began to combine, first forming ionized atoms of hydrogen and later some helium. These ionized atoms of helium and hydrogen attracted electrons, turning them into neutral atoms. As a result, the light was able to travel freely for the first time ever, since it was no longer scattering off free electrons. What does it mean? The universe was no longer dark. At the same time, it was still about a few 100 million years after the Big Bang before the very first sources of light started to appear. That's when the cosmic dark ages came to an end. We don't know for sure what this universe's first light looked like or how the first stars formed. Luckily, we have the James Webb Space Telescope to help us find the answers. How come? All because this is an infrared telescope. Why is it important? Let's figure it out. Imagine a star. It's a very, very old star, maybe the first star out there. Light leaves this star 13.6 billion years ago and settles off on an incredible journey through space and time. It needs to get to our telescopes. By the time this light reaches us, its color or wavelength shifts towards red. That's something we call a redshift. It happens because when we talk about very distant objects, Einstein's theory of general relativity comes into play. According to it, the expansion of the universe also means that the space between objects stretches, making them move away from one another. But that's not all. Light stretches too, which shifts it to longer wavelengths. Eventually, this light reaches us as infrared. In other words, redshift means that light that is originally emitted by the first stars or galaxies as ultraviolet or visible light gets shifted to redder wavelengths by the time we catch a glimpse of it here and now. For the farthest objects with very high redshift, that bare minimum of visible light is shifted into the near and mid-infrared part of the electromagnetic spectrum. That's why to see those space objects, we need a super powerful telescope. And if we talk about the Webb telescope, it can see back to about 100 million to 250 million years after the Big Bang, which is incredibly awesome. So by observing the universe at infrared wavelength, James Webb lets us see things no other telescope has ever shown before. The primary goal of this incredible piece of equipment is to study the formation of galaxies and stars that formed in the early universe. To look that far back in time, we need to look deeper into space. All because it takes light time to travel back from there to us. So the farther we look, the further we glimpse back in time. To find the first galaxies, James Webb is going to make an ultra-deep near-infrared survey of the universe. Then it'll follow it up with a few other methods of research. Now, as you remember, the gas between stars and galaxies in the early universe was opaque, and energetic starlight couldn't penetrate it. But then, about 1 billion years after the Big Bang, it suddenly became completely transparent. Why?
the James Webb Telescope might have found the reason. At one point in the past, the first galaxy's stars emitted enough light to ionize and heat the gas around them. This helped clear the view over hundreds of millions of years. The newest insights scientists got were about a time period called the era of reionization. That's when the universe underwent some dramatic changes. After the Big Bang, gas in the universe was unbelievably hot and dense. Hundreds of millions of years passed, and it cooled down. But then, something baffling happened. It was as if the universe hit the repeat button, and the gas became ionized and hot once again. It could have happened because of the formation of early stars. After that, millions of years later, this concoction became transparent. For a long time, researchers have been hoping to find definite evidence that could explain these changes. And now, the telescope has finally shown that those transparent regions are located around galaxies. Astronomers have seen these galaxies reionize the gas surrounding them. Even better, they've managed to measure how large these transparent regions are. They're ginormous compared to the galaxies themselves. Imagine a hot air balloon, and now imagine a pea floating inside. You've got it, and guess what? These tiny galaxies drove the entire reionization process, clearing huge regions of space around them. These transparent bubbles kept growing until they merged and caused the entire universe to become transparent. The research team chose to target a period of time before the end of the era of reionization. At that time, the universe was not quite opaque, but not quite clear either. It was a patchwork of regions of gas in different states. To find out this cool fact, the astronomers aimed the James Webb Telescope in the direction of a quasar, an incredibly bright space object. It acted as a giant flashlight, traveling towards us through different regions of gas. It was either absorbed by the patches of near opaque or moved freely through the areas where the gas was transparent. The scientists then used Webb to examine galaxies in that region of space. They found out that these galaxies were usually surrounded by transparent regions with a radius of about 2 million light-years. For comparison, the area the galaxies cleared was almost the same distance as the space between our home Milky Way galaxy and our nearest neighbor, the Andromeda galaxy. And the telescope witnessed those galaxies in the process of clearing the space around them. It was the end of the era of reionization. Until then, no one had evidence of what caused reionization. The team is planning to dive into research about other galaxies in 5 additional fields. The Webb telescope's results from the first field have been overwhelmingly clear. And even though the astronomers had expected to identify a few dozen galaxies existing during the era of reionization, they actually managed to spot 117. Now, let's talk a bit about the main hero of today's show, the James Webb Space Telescope. It's an absolutely stunning piece of equipment which is around 100 times more powerful than the Hubble Space Telescope. And the latter has observed places that are 13.4 billion light-years away. The James Webb Telescope is also on the pricey side, to put it mildly. Even though originally the cost of the telescope was estimated to be just $1 to $3.5 billion. The whole development process cost around $10 billion. For comparison, it cost NASA $4.7 billion to build and launch the Hubble telescope, and it was another $1.1 billion to fix it in orbit. Even though the James Webb Telescope itself is 3 stories high and the size of a tennis court, its mirrors are the lightest large telescope mirrors of all time. During the manufacturing process, they underwent a 92% reduction in weight. When you look at them, the telescope's mirrors seem to be gold, but in reality, they're made of beryllium. This is a steel gray, lightweight, and brittle metal. A gold coating is applied to each mirror, that's true, but they can't be produced entirely out of gold, since this precious metal tends to expand and contract, even with small temperature changes. So the total amount of gold in the James Webb Space Telescope is less than 2 ounces. That's a golf ball-sized piece of gold. And the gold plates covering the mirror are less than 1,000 atoms thick. As for the telescope's abilities, it would be able to clearly see a US penny from 24 miles away and a football from 340 miles away. James Webb's telescope side is cooling itself down, and its temperature doesn't rise higher than minus 370 degrees Fahrenheit. That's cool enough to make liquid nitrogen. A truly enormous 5-layered sun shield surrounds the telescope and reflects away as much sunlight as possible, letting the telescope stay cool.
Now imagine a place where a single day lasts longer than a whole year. On Venus, a day, meaning one full spin on its axis, is as long as 243 Earth days. And what's even weirder, despite the fact that Venus is experiencing a never-ending day, it has a shorter year than Earth. While Earth takes about 365 days to complete one orbit around the Sun, Venus does it in just 225 days. So, somehow, for Venus, a day is more epic than a whole year. Venus is a strange planet in general. It's called Earth's twin because of how alike we are, although it's a bit smaller than Earth. But there are some drastic differences too. For example, it spins in the opposite direction, which means the Sun there rises in the west and sets in the east. And Venus isn't the only one who dances to its own rhythm. Uranus does that too. And finally, Venus is quite crazy in terms of its atmosphere. When you stand on Earth, you don't really feel the weight of the air around you. Well, on Venus, that feeling would be like having an elephant sitting on your shoulders. Venus has 90 times the atmospheric pressure of Earth. The atmosphere there is a thick layer of toxic gases. For example, carbon dioxide that's released by all the volcanoes. It presses down with incredible force. This results in very hot temperatures. No wonder it'll take a long time before we'll be able to stand on this planet. Meanwhile, Mercury, the closest planet to the Sun, has an even more speedy orbit than Venus. It completes a full journey around the Sun in just about 88 Earth days. However, it has a slow spin on its axis, which means that one day on Mercury takes about 176 Earth days, basically half a year. Just like with Venus, a day there takes much longer than a year. Since it's closest to the Sun, no wonder Mercury experiences some super extreme temperature swings. Daytime temperatures can soar up to a scorching 800 degrees Fahrenheit, hot enough to melt lead. But wait for the sunset. At night, it drops to freezing minus 290 degrees Fahrenheit. Ooh! That's because Mercury doesn't have a thick atmosphere like we do, so the heat doesn't distribute across the planet evenly. If one side is in the dark, it'll be super cold, and the other side will be scorching hot, just like if you let a regular big rock lie down under the sun for a while. In fact, it's so cold that there might even be some ice on it. Look at the planet's North Polar region, especially those sunlit yellow spots inside craters. These are indications of water ice. Turns out water is much more common in space than we thought. Mars is often dubbed the Red Planet. It earns this nickname from the abundance of iron oxide, or rust, covering its surface. The iron-rich minerals create a rusty red hue that paints the Martian landscape. But it turns out Mars isn't just red. If you were standing on Mars, you'd witness desert-like butterscotch terrain with caramel and golden glows, some brown, and even a glimpse of a slight greenish hue. Mars also has the biggest mountain in the entire solar system, Olympus Mons, standing at a staggering height of about 13.6 miles tall. It's even taller than Mount Everest. It was formed by the volcanic eruption yielding low-viscosity lava, creating a shield-like structure. Since Mars is covered in sand, it's also famous for its crazy dust storms. But it turns out they're even more insane than we thought. These storms can last for months. While they might present challenges for future human missions, they also contribute to the planet's mesmerizing appearance when observed from afar. And not only storms, but even its own Mars quakes. Also known as seismic tremors, they were first detected by NASA in 2019. Unlike earthquakes that are often triggered by tectonic plate movements, Martian quakes are thought to result from the cooling and contracting of the planet's interior. It's interesting how similar, yet how different the planets are. Saturn's iconic rings might hold a secret link to Earth's ancient past. The rings are composed mainly of ice particles and debris and are estimated to be relatively young in space terms, perhaps just a few 100 million years old. Now, there are some theories that propose that they were born after some catastrophic event. For example, the collision of two large moons or the breakup of a comet. What's interesting is that this timeline coincides with the age of the dinosaurs' demise on Earth. Could there be a connection? Who knows? By the way, while Saturn takes the crown for its rings, it's not the only planet in our solar system sporting them. Jupiter, Uranus, and Neptune all have their own set of rings, although they might not be as visible and cool as Saturn's. However, there's something where Saturn truly stands out: the magnificent hexagon at its North Pole. It's a colossal six-sided figure. Each side of this incredible structure measures around 9,000 miles long, which is 1,200 miles longer than the Earth's diameter. Scientists aren't sure how it was formed or why. They think it might be due to varying wind speeds, or maybe it's shaped by a localized, slow, meandering jet stream. So far, it remains another of Saturn's mysteries. Much like Saturn's hexagon, Jupiter also has its own weird spot. It's called the Great Red Spot. This is a storm that's been raging for at least 350 years and is larger than Earth itself. Despite its name, the spot's coloration has varied over the years, ranging from brick red to pale salmon. Scientists continue to study this enduring storm, unlocking the mysteries of its persistence and ever-changing hues. Meteorologically, the Great Red Spot is a powerhouse. It generates enormous pressure in Jupiter's southern hemisphere. Meanwhile, Jupiter itself is a powerhouse when it comes to magnetic fields. Its magnetic influence is colossal. It extends far beyond the planet itself and creates one of the largest and strongest magnetic fields in our solar system. Because of that, Jupiter is a source of intense radiation and mesmerizing auroras. While Earth's northern lights are breathtaking, Jupiter has something to offer too. The magnetic field interacts with charged particles from Jupiter's moons and the solar wind. This creates visually striking auroras near its poles. But compared to Earth, the scale of these auroras is incredible, like nothing we've seen on our planet. But even having a cool big spot isn't a unique feature in our solar system. A stormy giant Neptune, the eighth and farthest planet from the Sun, also has its great dark spot. Just like Jupiter, it's a massive vortex in Neptune's atmosphere. But unlike its Jupiter counterpart, this spot tends to come and go because of Neptune's dynamic and ever-changing weather patterns. Neptune, together with Uranus, is known as an ice giant. And just like other giants, it boasts some of the most ferocious winds in our solar system. Its supersonic winds can get faster than 2,200 miles per hour. What a drama queen! But this explains its thick cloud formations. By the way, if you ever dreamed of a planet raining diamonds, you might want to visit this planet. Deep within Neptune's atmosphere, where pressures are extreme, scientists theorize that carbon atoms are compressed and form diamonds. And then, these diamonds might be raining down. What a unique touch to stormy weather. Neptune's moons got from their parent with the weird weather. For example, its largest moon, Triton, has a touch of cryovolcanism. Instead of spewing molten rock like Earth's volcanoes, Triton's cryovolcanoes erupt with a mix of water, ammonia, and nitrogen. Picture it as icy geysers shooting material into space. Seems like in our solar system alone, each planet has its own quirks and interesting qualities. Let's hope that we discover some more interesting things in outer space in the future.
They aren't supposed to exist. No one expected to find them. Scientists can't explain how they formed. And still, the James Webb Space Telescope has found them. These 6 galaxies, as massive as our home Milky Way, are full of mature red stars. They're so far away from us that they look like tiny reddish dots, even to this extremely powerful telescope. Astronomers have analyzed the light coming from these galaxies and estimated their age. They appeared 500 to 700 million years after the Big Bang. So far, nothing surprising. Galaxies that young aren't exactly rare. Scientists think that our first star clusters could have sprung up soon after the universe left the so-called Dark Ages. Those were the first 400 million years of its existence. At that time, only a thick fog of hydrogen atoms filled the cosmos. What is extremely bizarre about these galaxies is their tremendous size and the age of the stars inhabiting them. But this doesn't coincide with the existing ideas about what the universe looked like and how it evolved in its early years. Plus, it doesn't match with earlier observations made by the Hubble Space Telescope, Webb's less powerful predecessor. So, according to scientists, what are early galaxies supposed to look like? The answer is simple: young and small. And indeed, previously, most early universe galaxies we found were just space babies, blue and small. They seem to have appeared out of the primordial cosmic soup just recently, and were still building their early stars and other structures. Most young stars are actually blue. As they age, they acquire a reddish glow after burning through their star fuel and cooling down. That's why astronomers were not ready to see old red stars in those ancient galaxies Webb telescope was built to discover. Another thing they weren't ready to spot was galaxies more massive than 1 billion suns, and still, it happened. The most massive galaxies discovered recently seem to have masses just twice or 4 times lower than that of the Milky Way. And the most astounding thing here is that these galaxies were already that big when the universe was a mere 3% of its current age. But before astronomers start rewriting their theories, trying to explain how such huge galaxies formed so fast after the Big Bang, we need to make sure that what we're looking at isn't some other space phenomenon. Even so, most alternative theories need totally new concepts as well. One of them goes like this. Perhaps stars in the early universe emit light in some unusual, exotic way. And since astronomers didn't know about it, they didn't include this possibility in their models. Or our understanding of how stars form might be inapplicable to the early universe. If any of these theories turns out to be true, it'll overturn our understanding of star formation altogether. Now, how about we talk about the device that helped astronomers to discover those bizarre galaxies? The James Webb Space Telescope is an absolutely stunning piece of equipment, which is around 100 times more powerful than the Hubble Space Telescope. And the latter has observed places that are 13.4 billion light-years away. The James Webb Telescope is also on the pricey side, to put it mildly. Even though originally, the cost of the telescope was estimated to be just $1 to $3.5 billion. The whole development process cost around $10 billion. For comparison, it cost NASA $4.7 billion to build and launch the Hubble telescope. It was another $1.1 billion to fix it in orbit. Even though the James Webb Space Telescope itself is 3 stories high and the size of a tennis court, its mirrors are the lightest large telescope mirrors of all time. During the manufacturing process, they underwent a 92% reduction in weight. When you look at them, the telescope's mirrors seem to be gold, but in reality, they're made of beryllium. This is a steel gray, lightweight, and brittle metal. A gold coating is applied to each mirror, that's true, but they can't be produced entirely out of gold, since this precious metal tends to expand and contract, even with small temperature changes. So, the total amount of gold in the James Webb Space Telescope is less than 2 ounces. That's a golf ball-sized piece of gold. And the gold plates covering the mirror are only 1,000 atoms thick. As for the telescope's abilities, it would be able to clearly see a US penny from 24 miles away and a football from 340 miles away. James Webb's telescope side is cooling itself down, and its temperature doesn't rise higher than -370 degrees Fahrenheit. That's cool enough to make liquid nitrogen. A truly enormous 5-layered sun shield surrounds the telescope and reflects away as much sunlight as possible, letting the telescope stay cool. JWST is believed to be able to detect water on distant exoplanets. For a long time, astronomers have been discovering planets orbiting stars outside of the solar system by monitoring slight dips in stars' light. Such dips happen when planets pass in front of them. Plus, it's possible to read unique signatures in the light. This can tell us about a planet's chemical composition. And the strongest and most readable signatures happen within the infrared spectrum. And guess what? James Webb has state-of-the-art infrared instruments. They can help scientists spot new planets and even identify the presence of water there. The telescope was launched near the equator because Earth spins a bit faster there. And this gave the rocket some extra push. When the James Webb Space Telescope runs out of fuel, it'll keep orbiting the Sun indefinitely. On the other hand, even though the telescope wasn't actually designed to be serviced or upgraded, it might potentially be refueled with the help of robots. This would extend its lifespan. Interestingly, at first, astronomers were sure that finding something exciting with the help of James Webb would take time. They thought that the first discovered galaxies would be so small and dim that the telescope would only find some remote candidates at best. But it didn't go as planned. As soon as the first images were released, scientists started finding countless galaxies, bright, large, and impressively old. The competition is still on. One research group after another spots new record-breaking worlds. One astronomer even said that the scientific world was freaking out since no one had actually expected such impressive results. One of the main goals of the Webb telescope is to observe the light from the very first stars and galaxies in the universe. Unfortunately, the farther away an object is, the faster it's moving away from us. And the longer the light has to travel, the more it stretches towards the infrared side of the spectrum. This is called redshifting in astronomy. But thanks to its infrared equipment, James Webb can reveal previously invisible worlds to us. So, thanks to this telescope, we've managed to see incredibly distant galaxies that were born around 3.8 billion years ago. It means that the light JWST detected took more than 13 billion years to reach Earth. Can you imagine that? But one of these galaxies stands out from the rest. It appears to be the oldest galaxy astronomers have discovered so far. It's called Glass Z13, and it dates back to a mere 300 million years after the Big Bang. The previous oldest galaxy scientists identified was found by the Hubble Space Telescope, and it dates back to 400 million years after the Big Bang. During that scarcely probed era, the very first galaxies and stars started to appear. But how exactly did this process unfold? No one knows for sure, yet. It might have depended on the laws of some exotic physics, including the influence of dark matter and dark energy, or some poorly investigated communication between gas, dust, and starlight. With the help of the Webb telescope, scientists can now test their theories about what was happening out there after the birth of the universe.
Hundreds of diplomatic spaceships take off from Earth and head into space. When they reach their destination, they're met by hundreds of alien ships. This is humanity's first contact with an extraterrestrial civilization. People managed to detect them not so long ago, in a star system very close to our home. It's Proxima Centauri. This red dwarf star is the closest to our solar system. It's 7 times smaller than our Sun, which makes it only 50% bigger than Jupiter. Proxima Centauri is also 8 times as light as the Sun. This star system is 4.2 light-years away. That's how long it takes a photon of light to travel from this star to Earth. By comparison, it only takes 8 minutes for sunlight to reach our planet. If you decided to travel to Proxima Centauri, It would take you about 73,000 years to fly there in a conventional rocket. That's longer than our intelligent civilization has even existed. But it's not the star itself that interests us. It's the planet orbiting it. That's Proxima Centauri B. It's 17% bigger than Earth and about 10% heavier. It orbits its star at a distance of 4.5 million miles. By comparison, Earth is 93 million miles away from the Sun. That's 20 times farther. But the host star, Proxima Centauri, is a red dwarf. It doesn't emit as much light and heat as our Sun. So the planet Proxima Centauri B is right in the habitable zone of the star. It's located at such a perfect distance from its mother star that the planet neither gets too hot nor turns into a block of ice. In other words, the temperature there makes it possible for water to exist in its liquid state. This means that Proxima Centauri B could host life. But further observations of the planet make it doubtful. The host star is very unstable. Its brightness changes too frequently. In 2017, astronomers witnessed a catastrophic flash. The star increased its brightness by 1,000 times for 10 seconds. Before that, there was another weaker flash. The planet received an enormous amount of radiation. If there had been life there, that flare would have wiped it out completely. Overall, Proxima Centauri B receives about 400 times more X-rays than Earth. Complex living organisms cannot live under such conditions. Scientists say that even if there was an atmosphere and an ocean on Proxima Centauri B, this constant radiation would simply blow them off the planet. Proxima Centauri B is so close to its host star that it's gravitationally locked to it. This means that the planet is always turned to the star with only one side, just like the moon is turned toward Earth. That means that only one side of the planet receives this awful amount of radiation, and some experts speculate that an intelligent civilization might live on the night side of the planet. And it could be this civilization that sent us the strange signal that astronomers caught in 2019. Scientists described it as, quote, a bright long-duration optical flare, accompanied by a series of intense coherent radio bursts. This radio signal was observed for 30 days by one of the radio telescopes on Earth. Scientists thought the signal was artificial and could have been sent by an extraterrestrial civilization. Presumably, the signal came from Proxima Centauri B, or one of the moons that might be in that star system. But further observations failed to detect the signal. Now, the main theory claims that this radio signal is just some kind of interference from some technology on Earth. But what if it was really sent by a civilization living on the dark side of Proxima Centauri B? Well, we may soon find out for sure. People are launching a brand new telescope into space. It's the James Webb Space Telescope. It's scheduled to be launched at the end of 2021. A booster rocket will take off from Earth and reach orbit. Then, it'll deliver the telescope to a specific point between our planet and the Sun, where their gravitational forces are roughly equal. Plus, there's no light pollution in space, unlike on Earth's surface. There are also no clouds or other weather conditions that might interfere with the telescope. The James Webb Space Telescope will replace the Hubble telescope, which has been operating in space since 1990. The new telescope costs $9.8 billion. And here's why. It'll use a mirror as wide as a boxing ring. This will allow the telescope to see very far into space. So far, in fact, that the light from some events happening there won't have reached Earth yet. This means we will literally be able to look back in time. The James Webb Space Telescope will see the universe almost immediately after the Big Bang. We'll see how the first stars and galaxies were born, and how the universe turned into what we observe today. But also, this telescope can be used to examine Proxima Centauri B. Astronomers will be looking for artificial light there, like the LED lights we have on Earth. If Proxima Centauri B really hosts life on its night side, then the locals must have learned to transfer heat and light from the day side of the planet, and they would have to use artificial light to support life on their side. The James Webb Space Telescope is powerful enough to distinguish the light waves emitted by the star from those that might be created by someone on the dark side of the planet. And if we do detect some artificial light, we'll have the first ever confirmation that an intelligent civilization might exist outside our solar system. But there's always room for error in calculations and data interpretation. The only way to establish the truth once and for all is to send a space probe to Proxima Centauri. Then we can get real pictures of the planet. The main problem is distance. Although Proxima Centauri is the closest to the Earth star system, it still takes tens of thousands of years to get there. After all, the Voyager 1 space probe needed about 44 years just to leave the solar system. And that's just a small step compared to the actual distance to the nearest star. So we need other methods of travel, and they have to be much faster. Some scientists want to send microprobes to Proxima Centauri B. They won't be any heavier than a sewing needle. A launch vehicle will deploy about 1,000 of these probes into orbit. Then they will unfold a space sail. This is an ultralight material that will use the power of light to create thrust. When the sail is deployed, we'll focus a powerful laser beam onto it. This will accelerate the probes to about 20% of the speed of light. This will be an absolute speed record by our standards, but it'll still take about 21 years for these probes to reach their destination. And we'll have to wait for about 4 more years just to get the first signal from them. The Proxima Centauri star system isn't the only potential world to host life, and one of the tasks of the James Webb Space Telescope is to look out for other worlds. The telescope's powerful instruments will allow it to find relatively cold planets where temperatures are close to those on Earth. We'll be able to study in detail around 24 nearby star systems, and we'll be able to detect not only planets themselves, but also their moons. Scientists expect a boom in the discovery of exoplanets. From the start of the telescope in 2022, we'll constantly be detecting new worlds and learning more about those already discovered. The James Webb Space Telescope will allow us to better study our own solar system. Jupiter's moon Europa, for example. Scientists believe there might be water there. Although Europa looks like a block of ice, the moon's gravitational interaction with Jupiter heats its core. That likely makes the ice deep below the surface melt. So there's likely to be an ocean under the ice crust. Similar conditions could exist on Enceladus, Saturn's moon. This moon is geologically active. There are geysers that burst out of the cracks on the moon's surface. The James Webb Space Telescope's infrared instruments will be able to explore Europa and Enceladus in search of biosignatures. Those are the traces of life activity of living organisms or bacteria. This telescope is scheduled to operate for about 6 years. But in the future, we'll launch an even bigger one. It's called LUVOIR, which stands for the Large UV Optical Infrared Surveyor. Its mirror will be twice the size of that of the James Webb Space Telescope, and almost 7 times the size of the Hubble's. The telescope is scheduled to be launched in 2039. We'll get it into orbit with the help of a super heavy rocket. Then we'll have to deliver the telescope to its destination, 1 million miles away from Earth. And then it'll begin its observations. We could learn to travel faster than the speed of light by that time. Then, if we find a potentially habitable planet with the help of the telescope, we can send a space probe, or even a team of explorers there. In this case, a diplomatic meeting with an extraterrestrial civilization might become a reality. Wow, the James Webb Telescope has been fully deployed. If you're interested in astronomy or space, you've got to be excited about the James Webb Space Telescope. Here's why. For starters, it's huge. How huge? The primary mirror of the JWST is over 21 feet wide. The Hubble Space Telescope, the previous largest eye in space, has a mirror of about 7 feet, 10.5 inches. By comparison, if you place the two telescopes side by side, it'd be like putting a horse next to an elephant. And elephants are enormous. There's a perfect reason why the Webb, as it's affectionately called, is massive. It has to be huge because it's not an optical telescope in the traditional sense that most telescopes are. The JWST is an infrared telescope. It sees heat. Infrared light has a longer wavelength than visible light, so it needs a larger mirror to focus that light. So what do we have here with the James Webb Space Telescope? We have two never-before things going on. We have incredible technology and incredible science missions. Both the missions and the technology are out of this world cutting edge. The Webb is a classic example of engineering in the service of science. Because of its greater light-gathering power, the James Webb Space Telescope will be able to take images of things that we were never able to see before, but have always wanted to see. Things like exoplanets and the first galaxies in the universe. and stars and planets forming inside nebulae. And you can bet that there'll be plenty of surprises too. The James Webb Space Telescope has several technological tricks up its sleeve, which promise to provide its greatest scientific discoveries. The Webb has a coronagraph, and a very special coronagraph at that. The coronagraph is the tool that will allow the first real pictures of exoplanets. The coronagraph blocks out the bright pinpoint light of stars, which we already know have planets orbiting around them. Without the coronagraph, the starlight would make things too bright to see these planets, because planets are hundreds of thousands of times dimmer than the star. But with the coronagraph blocking the starlight, the exoplanets come into view. And the JWST coronagraph can block the light from up to 100 stars at once. We can expect a swarm of exoplanets. This brings us to the next high-tech gadget the JWST has up its sleeve, a no-slit spectrograph. Usually, an ordinary spectrograph will have a slit to allow a sliver of light to enter and be diffracted. Diffraction is the scattering of light to reveal the spectrum of the light's component wavelengths. But the James Webb Space Telescope's work is so sensitive that a sliver of light would overwhelm the optics. So a no-slit spectrograph was installed. The starlight gathered from the big mirror is sent into a fiber optic cable to send only a single spot of light into the spectroscope. And that's where the grism takes over. Sir Isaac Newton used a prism to discover the spectrum of sunlight, Roy G. Biv, as you may recall. But the Webb uses a grism. That's a compound word, like smog, which is smoke and fog. A grism is a graded prism. That means it has itsy-bitsy, teeny-tiny grooves that diffract the spot of light the big mirror sends down the fiber optic cable and into the spectrograph. The science of reading a spectrum of light is called spectroscopy. By analyzing the spectra of light from the exoplanets, the JWST will determine what gases are in the planet's atmospheres, as well as their density and even their temperature. It's an incredible advance in our knowledge. We'll be able to tell if a planet has oxygen or nitrogen, or methane, and other gases that may or may not indicate that the planet is habitable. Another Earth, perhaps. Presently, the JWST is parked in its permanent location. Unlike the Hubble Space Telescope, which orbits the Earth, the James Webb Space Telescope orbits the Sun. It orbits the Sun at one of the gravitational balance points between the Earth-Sun system. It just stays there without having to use much or any fuel to hold its position. So, as the Earth orbits the Sun, the James Webb remains parked at a spot that is also orbiting the Sun. There are 5 gravitational balance points between the Earth and Sun. They are called Lagrange points, after their discoverer, Joseph Louis Lagrange, in the 18th century. The Webb is parked at L2, the second of the 5 Lagrange points, which lies 932,000 miles out into space, way beyond the Moon. All this to observe a spot of infrared light. But first, the engineers must get, or acquire, that spot of light. To get a spot of infrared light, the 18 hexagonal mirrors had to be unfolded from their position inside the Ariane rocket that sent the Webb into space. Once the mirrors have unfolded, their positions must be adjusted to microscopic level accuracy so that all 18 mirrors produce a single image. Several tiny motors are attached to each mirror segment to make these adjustments. These motors, which must be activated individually, will gradually pull the honeycomb-like mirror segments into alignment. It's a critical part of the mission and takes months to complete. To align the mirrors to produce a single spot of light, the James Webb Space Telescope can't be jiggling around. The telescope must be kept absolutely motionless, and that requires 2 other cutting-edge technologies, the sun shield and the cryocooler. In space, direct sunlight is very hot, and shadow is very cold. Therefore, the James Webb Space Telescope brought along its own high-tech sun shield. It's huge, too, as big as a tennis court huge, comprised of 5 individual layers of Kapton film, only a millimeter thick. Each layer of the sun shield has to be remotely deployed individually using a system of 8 motors and 139 actuators with thousands of parts. The purpose of the sun shield is to help the JWST stay cold. The colder the better. And colder is what the cryocooler is for. Temperature can be measured 3 different ways: in degrees Fahrenheit, where water freezes at 32 degrees and boils at 212; in degrees Celsius, where water freezes at 0 degrees and boils at 100 degrees. But neither of these thermometers have a starting point. So, Lord Kelvin, in the 19th century, devised a third temperature scale, the Kelvin scale, which starts at absolute 0, the coldest temperature possible. The onboard cryocooler will cool the JWST to just 7 degrees Kelvin, 7 degrees above absolute 0. At this temperature, virtually all heat from motors is removed, and the telescope will be able to focus the light to a point without any noise, basically any motion interfering with the quality of the image. Finally, after all this incredible technology functions remotely as planned, we are almost ready to observe the infrared images from the giant multi-segmented mirror of the James Webb Space Telescope. Almost ready. A telescope can collect all the light it wants, but in the end, it must also be able to detect what it's collected. If the light is not detected, it's not truly observed. Enter the pièce de résistance, the infrared detectors. The Webb has 15 of them. The specially fabricated semiconductor material produces a slight electrical charge when struck by a photon of infrared light. The Webb's infrared detectors can produce a 1,000,000-pixel high-def image. A few of the detectors can produce a 4,000,000-pixel image. They must be durable enough to last 10 to 20 years without warping or corrupting, all while working at 7 degrees above absolute 0. In themselves, the infrared detectors on the JWST are an engineering marvel. But what are they going to take pictures of? The missions of the JWST. Well, they're cutting edge too. 70 of the first 280 target observations are exoplanets. Is there another Earth? Which exoplanets seem habitable? The Webb telescope will provide detailed spectroscopic analysis of the atmospheres of thousands of known exoplanets. For the first time, we will see images of exoplanets as they appear in infrared light. Cosmology, the study of the universe, is perhaps the primary mission for the Webb. Galaxies receding away so fast that their light is stretched into the infrared will be a prime target for observation. Hundreds of hours of observations are necessary to collect the faint infrared light from these first galaxies formed after the Big Bang. The JWST will give us a picture of what the infant universe looked like. Astronomers will learn new information about the dark energy that is driving the expansion of the universe and what role, if any, black holes play in the formation of galaxies. Star formation in the Milky Way and nearby galaxies is also part of the mission of the James Webb. By imaging hundreds of solar systems forming around newborn stars, astronomers will establish a definite history of solar system development. Now fact will replace theory, and a big step forward will be taken in our understanding of space. The James Webb Space Telescope is a bold endeavor that will mark an epoch time in scientific history.